Today we're going to talk about proportions and scale drawings. So, a scale drawing it can include any of the following. We might be talking about maps, models, and in general really any type of object. All right. And a scale drawing usually represents a real thing. All right. Now, these scale drawings are usually some type of an enlargement, which means it is larger than the real thing. Or it could be a reduction, which means it is smaller than the real thing. All right. Now, when we work with these types of proportions in scale drawings, all right, we are always given a scale ratio, all right? Sometimes it's called a scale factor, means the same thing. And it's always written in one of three forms. It's written either A to B, A to B, or in fraction form A over B. And we've seen a lot of that this year, so we know just what that means. Now, when it's written in fraction form, all right, and we always want to remember that we have a numerator, and then we have our denominator. All right, and always, the numerator is always going to be the number that corresponds to the map, to the model, to the drawing, all right? And the number in the denominator is always going to be the real object, all right? Now, let's go ahead and start with an example. So let's say we are looking at a map, and on this map it tells us that the scale is 1 inch equals 25 miles, all right? And so we know if we write this in fraction form, this would just be 1 inch represents 25 miles. And let's say we have the following representation of a little map. And first we are going to just put a disclaimer here that this is not drawn to scale, all right? So don't be misled by the numbers per se, all right? So we're going to say up here, this is Bugville. Down here is the town of Wormley. And down here, down south, we have B-Town. Now, on this particular map, it tells us that between Bugville and Wormley, it's 90 miles. So we might have the question, the first question might say, so how many inches is it on the map from Bugville to Wormley? All right, so we set it up like a proportion. But with this type of a scale drawing proportion, all right, I always put and label my ratios. In this case, my object is the map, and I always write the word real in the denominator. That keeps me in the right track as far as where to put the numbers. And our first ratio is always our scale factor here. So we know that on the map, 1 inch on the map represents 25 miles in real life. So there's our first ratio in our proportion. And to set up our second one, we are given that it's 90 miles. 90 miles is the real thing, so that means 90 goes in the denominator. and n is what we're looking for, the inches on the map. All right, so we set up our proportion, our equation using our cross product. So 25n equals 90 times 1. So 25n equals 90. And if we divide both sides by 25, n is going to equal 3.6 inches. So it would be 3.6 inches on the map. Like I said, it's not really drawn to scale, but that would be the real answer. All right. Now, for our next question, we are going to look at the distance from Bugville to B-Town. And let's say we measure it, and it measures 6.5 inches. And our next question, right, would then be, how many miles is it from Bugville to B-Town? So again, we're going to write map over real, and our given scale factor is 1 inch represents 25 miles. So the information we were given of 6.5 inches is the measure on the map, so it goes up here in the numerator, and what we're looking for is the real miles. So this is our unknown, and so now we write our cross product. So 1n equals 25 times 6.5. So 1n equals 162.5 miles. All right. Now, let's talk about doing a proportion when we are using a model. So let's say we have a little model here of a dresser. Let's just say and let's give it 3 little drawers and a handle. Now let's say this model measures 5 inches. So I've got a little model which actually measures 5 inches. So we really want to know, how tall is the real dresser? So we have to have been given a scale, and it says how tall is the real dresser. All right, and we'll say if the scale is 2 inches, really represents 1.5 feet. So again, let's label our proportion. So in this case, it's a model instead of a map. So model over real. And the given scale was 2 inches represents 1.5 feet. So in this case, we are given the 5 inches. The 5 inches is the measure on the model. So our 5 inches would be here, and the real measure is what we're looking for. So we would write our equation using cross products. So 2n would be equal to 7.5. And when we divide by 2, n is going to equal to 3.75, I believe. Let's see, 7.5 divided by 2, go 3, carry the 1, that would be 7, and that goes exactly 5. So 3.75, not inches, sorry about that. That would be 3.75 feet tall, okay? Because our measurement for the real thing is always in feet, so we got to make sure that that is also in feet. All right. Now, let's talk about an example where we have a drawing. So let's say that we have a photographer who has a photo of the Brooklyn Bridge. And he wants to make a poster out of it. So we'll say the original measures 4 inches by 5 inches. All right. And just a reminder, whenever we are given measures like that, the assumption is this is length times width. So the first measure is always the length, the second is always the width when you're asked in questions. And he wants to enlarge the photo using a scale of 1 to 9. So let's see what that really means as far as making a poster out of that. So if we have a 4 by 5, essentially we have a little picture, all right, that would be 4 by 5. If we're going to enlarge it and use a scale of 1 to 9, we actually have two problems here. We have to calculate the length and we have to calculate the width, all right? So again, we're going to start with our model over real. And since we're using a scale of 1 to 9, 1 inch would represent 9. So the length was equal to 4. So how long should the new length of the poster be? So using our cross products, we would have 1n equals 9 times 4, and would be equal to 36 inches. So the new length would be 36 inches. On the width, again, we still have our model over real. The ratio is 1 inch represents 9 inches. And in this case, the width measures 5 inches. So that would be n. So 1n equals 9 times 5, and would be equal to 45 inches. So we'll just come over here. So the poster, the new measurements on the poster would be 36 inches by 45 inches using a scale of 1 to 9. Okay? Right. Next type of question you might also see in this area is when they ask you to find the scale. All right. So you may be given some measurements and they want to know what scale was used to create the enlargement or the reduction. So let's say that you have the model of an airplane. Okay. And the model is 6 inches long. And so if the actual airplane is 80 feet long, all right, what scale was used to make the model? Okay, so again, we're going to set it up as model over real. And we know that 6 inches on the model represented 80 feet for the real thing. So we're just going to set our model to 1 inch, and the real item is where we're going to put our unknown n. So again, we're going to use our cross product. 6n equals 80 times 1. So 6n equals 80. And when we divide by 6, we are going to get n equals 13.3. So the way that we would write the scale is that 1 inch represents 13.3 feet in the real thing. So 1 inch on the model represented 13.3 feet.